Hello everybody, welcome back to another video. This video is going to be on data structures and algorithms, which is a key component in any software engineering job. This is going to be a bit less of ethical hacking. It's actually going to be discussing stuff about coding, like software engineering and software development. These are the types of questions that will be pulled from the questions that will be pulled for interviews for software engineering would be on data structures and algorithms, so it's very key to understand what they actually are. So yeah, this video is going to be a bit more on coding rather than ethical hacking, but we're definitely going to go through some of these presentations with ethical hacking as well. So what actually is an algorithm? So an algorithm is just simply a set of instructions that is followed in a specific order for a specific problem to a solution. So let's say you wanted to make a cup of coffee, you would have to get the cup out of the cupboard first, you then have to boil the kettle to make it hot water, you then add the coffee, add the water, and technically this is considered an algorithm, but normally algorithms are for computer science and cybersecurity, but as an algorithm is just a set of instructions to be followed in a specific order, then anything can essentially be an algorithm. So what actually is a data structure, and what are data structures in general? So they are ways to store values in a specific way when programming. It allows the coder to put values into a structure that keeps tabs on their locations in like the actual data structure itself. There are many data structures out there. For example, in Python we have ones that are primitive and ones that are non-primitive, which basically means the coder creates them if they're non-primitive, and if they're primitive then they're already built in. So for example, as primitive data structures, we've got ones in Python like boolean, string, float and integer, and then we've got non-primitive ones, stuff like lists, arrays, stacks, queues, trees and various more. So that's some of the stuff we'll be discussing today. So an algorithm example, so this is a screenshot I put together. It's just a snippet of code that just explains a very simple algorithm. So basically what happens is it initializes a variable 1, and assigns the value 2 to it. And then what happens is that variable gets printed out, so the value actually gets printed and outputted. And then what happens is we then have another variable called variable 2, which adds on 10 to the previous variable and then prints that out. So then variable 2 will then be 12. As you can see, we have 2 and we have 12 because the first variable is number 2, as you can see here, and the second variable will be plus 10 onto that, so 2 plus 10 is 12. So types of data structures, so there's various different types of data structures for different programming languages, but it kind of depends on the ones that you're choosing, but there are a few common ones. All coding languages will generally have the same basic ones, but then there is some more depending on the ones that you choose. So we've got ones like stacks. So stacks are a non-primitive data structure that can be used in Python. They store values as they are entered into the actual stack. So if an item was added onto the stack, it's called pushing, and when it's taken off, it's called popping. Items, when stored, go at the top of the list, and then more that get added on, then the first one goes to the bottom. The top item will always leave the stack first, and the bottom item will always be the last to leave. It uses last in first out, or LIFO. If you enter 13 on a stack and then 5 more numbers, 13 will be therefore at the bottom of the stack and will be popped off at the end, like at the very end after everything else has been popped off. So you've got a little diagram here. So we've got push and we've got pop. So you can push values on, and then you can also pop them straight off, but they have to come from the top. Here's a little example of a stack. So as you can see, Python has some built-in methods, stuff like .append and pop here. As you can see, popping is actually taking off the last value that was entered onto the stack. So that's what this part displays. And as you can see, we can add new items with append and things like that as well. So this is just a simple example of how a stack is used for OOP in classes. So a queue is a type of non-primitive data structure that can be used in Python. They can store values as they're entered, but they are stored linearly, not necessarily like a stack, which is like vertical. It is represented by a horizontal box separated into sections. There are also pointers. So pointers stay at the front and the back of the queue, just to keep track of where the front and the back is. Think of it as like a snake, that you've got the head and the tail. When you want to pop off an item, you can use dequeue, and for adding you can use onqueue, which is the same as popping and pushing. A queue uses FIFO, which is first in, first out, which is the opposite of LIFO, which was for stacks, which is the opposite of a stack, like I've just said. So as you can see, this is an example of a queue. this is the front, and you can on cue, so you can add, oh, this is the rear, and this is the front, and then you can DQ, so it pops off on this end, and you can add on to this end, and it goes through like that. So we also have things called trees as a data structure. They're quite common, especially for interview questions, especially with a demonstration as well, so like a scenario. So it's also good to just know exactly how to work out trees. So a tree is just another type of data structure that is often used. There is also a subsection called binary trees, which we'll also get into, but it determines the output of the program based on 2 inputs. So with a tree, the input leads to one other output, I should say, then follows down the tree based on the previous decisions. Each line in the diagram is called a branch, and then the actual circles are called nodes. The end node is called the terminating node, and the top node is called the parent node. The lower nodes can also be called child nodes, depending on how you wish to explain it. So this is an example of a tree. So right up here you have the parent node, you then have the branches down here, like these are all branches, these lines, and then all of these circles are called nodes, and then the ending ones are called terminating nodes, which are these ones right here. So a little bit on binary trees. The main difference between a tree and a binary tree is that a tree is arranged data into similar to a tree in a hierarchical manner, whereas a binary tree is just a type of tree in which can only have 2 child nodes, like this one right here. So the usefulness, so data structures and algorithms kind of go hand in hand, especially for, like I've said, software engineering and coding jobs. Most interviewers will often pull questions around this topic for the actual candidates for interviews. So it's very good to understand how they all work and what they actually are. You may get some questions like, they just want to find out if you actually know what they are, but generally they'll give you some sort of scenario, and the underlying nature of that scenario would be to use one of these data structures or algorithms. You can learn Python for free. See my previous YouTube video on how I did that. Actually, I've got an upcoming YouTube video. It's not out yet, but it's how I actually learned Python. So that should be coming out soon. Online can really definitely help, and this also can be free. I wouldn't necessarily pay for things like this unless it's something like brilliant.org, AlgoExpert, or maybe even the professional version of LeetCode. I'm not sponsored by any of them yet, but yeah, so it's just any of those, but you can also learn it on YouTube and things like that as well. So yeah, like I've said, you've got 3 schools here, which is really good for learning various different things about coding. So you've got like website development, you've got ethical hacking, you've got just coding in general, Python, so this is really good. You've also got LeetCode, which is very good. If you ever watch Joe Tech, he also talks about LeetCode quite a fair bit. It's really good for prepping for interviews. And then of course you've got AlgoExpert, and you've also got brilliant.org as well. Tech with Tim on YouTube is actually really good for learning Python. He's actually worked at like places like Microsoft before, and he's he does various videos on like Python and just SWE in general. SWE is like software engineering. So a little bit about this channel. So it obviously focuses on computer science as a whole, but also kind of divides itself into coding and also ethical hacking specifically. I've created this channel to help people learn new skills and concepts that may feel hard for them to learn originally, as they might be overwhelmed by information and like where to start learning. I also make sure that I provide content that actually helps them overcome this barrier. I'm also really proud of my work and also the videos, as I've helped a lot of people. It's kind of into the thousands now, I think. Quick tip for anybody who's wanting to start out: no matter how successful you are, you will always get haters. The only reason they exist is to push people further into success. You might see them laughing on group chats and forums, but simply ignore them because they're really at the bottom. It's just a quick tip because I know people kind of struggle with confidence and everything like that, and they want to do all of these fun things, but they feel like, oh, what if I get hate? Well, yeah, you just got to kind of block them out. You know, they're kind of at the bottom of the barrel, so you just kind of want to ignore them. And yeah, so hopefully this video has helped grasp some key concepts about data structures and algorithms to help practice them and stay up to date with them. Feel free to go on any of the resources that I've listed. Yeah, so just consider coding the structures that we've talked about today in your preferred programming language, and yeah, no, you should know them reasonably well. Please give a like and subscribe, and make sure to turn notifications on, as it really helps me grow my channel and to reach more and more people, so then they can learn much better. And yeah, like I hope you have a nice day, and I'll see you in the next one.